So in the last session, we talked about Docker containers, right? So we completed Docker images and Docker containers. So today we'll talk about one advanced topic and which is also very important. So which is how to configure your Docker engine or Docker daemon to listen to the TCP socket rather than listening on the Unix socket. Okay. And we'll also understand how to use Docker REST APIs. So these are the various things I will cover. Like we will see how to use Docker REST APIs, how to call them using curl commands, how to install only Docker CLI without Docker daemon, and then how to configure your Docker daemon to listen on the TCP socket. Okay. We'll also see, Docker CLI source code in the GitHub. So where Docker, clearly mentions the configuration, the default configuration related to communication between client and the server. Okay, so this will be quite advanced, and if you're not able to understand initially, do practice it twice so you'll able to understand it. So we know that by default, Docker daemon listens to the Unix socket inside the Docker host, right? So for example, if I log into my Docker machine, okay, so I'll become sudo. So if you look at the the socket file var run docker.sock. So this is the file that basically Docker daemon will listens to. Okay. So your client, basically whatever Docker CLI that we have will talk to Docker daemon using this unique socket at var run docker.sock. Okay. So this socket has root privileges so that it can do any operation. And if you look at the permissions, okay, the ownership of this socket, so it is owned by root user and the Docker group. Okay. So if anyone other than root user wants to talk to the Docker using this Docker socket, they have to be either root user or they have to be part of Docker group, right? That's the reason why we have used user mod to add EC2 user to the Docker group, right? So that EC2 user can also talk to Docker daemon using this socket. Clear? Right,
Clear.
guys? Okay, so this works only if you have client and the daemon running or available on the same machine. Okay. And if you want to know how this is configured in the client, because we know that Docker CLI by default uses this socket. So where exactly this is configured? So if you go to Docker CLI GitHub, okay, so where GitHub maintains, Docker maintains the complete source code of Docker CLI. And if you look at the options that we can provide to this client CLI, you have this hosts.go. Okay, so inside the host.go, we have constants. So where we have some default set. So like default Unix socket is var and docker.sock. Okay, so Docker daemon by default always listens on this Unix socket. Okay, but you can also configure Docker to listen on some TCP socket without TLS, to listen on this TCP socket with TLS. Okay, so by default, non-TLS port is set to, I think it is 2375. Okay, yeah, here. The default TCP port is 2375 and the default, HTTP port with TLS, that is transport layer security, is 2376. Okay, so what we will do is, along with this default Unix socket, we'll also configure daemon in such a way that it also listens to HTTP socket 2375, which is quite insecure. Okay. In the next session, what we'll do is we'll see how to establish TLS communication between your client and daemon. Okay, using certificates that I'll show you tomorrow. In that case, we will go for 2376 as the TLS port. Okay. Yeah, so now we understood that CLI by default talks to the daemon using this socket. Okay. So we'll understand a bit about, the Docker APIs, and then we will configure how to access Docker daemon over HTTP port. Okay. Using TCP protocol. Okay. So let me go to the Docker APIs. So APIs are meant for, basically, your daemon. Okay, so daemon exposes your APIs. Okay, before that, let's understand what are APIs. Okay, so API stands for Application Programming Interface, right? So if you have a server and if you have a client tool, so the server can listen to the client instructions over APIs. Correct. Which means APIs are meant for the server. Servers expose some APIs. So let's say this is a Docker daemon. Okay, so Docker daemon has certain APIs. So which client tool like Docker CLI or some automation scripts using Python, Golang. Okay, so they can use daemon's APIs to talk to the daemon. Okay, so what all things that we can do with the, with these APIs? Okay, specifically to Docker daemon, we can check its version, list all the images, create containers. It can be anything, but instead of directly using Docker client to like Docker run to create containers, we can use APIs of Docker daemon to create such containers. Okay, got it, guys? Okay.
Yes.
So here, for example, let's say, a delivery app. Okay, it can be anything. So it wants to use location-based services so that it can deliver the courier to the proper person. Okay, using the locations. So directly instead of creating their own mapping tool, okay, or mapping application, what they can do is they can directly use Google Maps APIs, okay, and integrate it with their app so that the app can use Google Map APIs to support location based tracking. So it is something like that. Okay, now REST stands for representational state transfer. So this is not a protocol, so this is a method or it is a style of communication. Okay, so that's the reason why we call it as REST APIs. Okay, so in most of the cases, REST APIs are meant to, give back information in the form of JSON. Okay, so when you have a client and a server, so when you talk to the server over the server APIs, server might return the information in the form of JSON because JSON is a representation of the information, JavaScript object notation. It is very easy to understand and parse. Okay. So there are many methods that we have in REST APIs, just like our HTTP methods. Okay, let's say I have a client tool and there is a server. Okay, so this server is, let's say, your daemon. Okay, your Docker daemon, or it can be any application. Okay, so using this client, what I can do is I can fetch information from the server or send some information to the server, update information on the server, or delete some information on the server. So the client can do anything on the server. Okay. So when we want to fetch information from the server, it is always known as GET, also known as HTTP GET. So using HTTP GET, you get the information from the server. Okay. So when you want to create resources on the server, okay, let's say I wanted to create a container. Okay, it is a new container. So then it is called as a post request. Okay, so when you want to send the post request to the server, you also have to send some information to the server, like what container image you have to use, what port number you have to use. So that extra information you need to pass in the body of the request. Okay, so when you want to delete the container, okay, or delete some information on the server, it is always a delete HTTP method. Okay, let's say you wanted to update some information. Okay, so like you have a container and you wanted to update some of the information. Okay, then it is called put. Put means it is different from post. Post will always create a new resource. Put will update an existing resource. Okay, if that resource is not available, put can also be used to create that resource. Okay, patch means, let's say you wanted to update certain parts in the server, that is called as a patch HTTP method. Okay, so this is a basic, these are some of the basics of HTTP methods and APIs. Okay, so let's say there is a server, you have a client tool, you have a client and you have a server. Okay, you wanted to get some information from the server. We know that it is a GET request. Okay, so when you send a GET request, okay, to a particular URL, okay, so this URL will be of the server. then the server will send an response to you. So mostly when we talk about RESTful APIs, the response will always be JSON, so that it is easier for you to parse. No HTML data, no image related data, nothing like that. So it will be plain JSON format. Okay, you ask server for the information. Like what information? Let's say the server is your Docker daemon. I want to know what all containers that are running. Okay, so the server will send back that complete information in the form of a JSON. Okay, so using JSON, I can see, how many containers are running, what image they are running, what ports are exposed, and all that stuff. Okay, and also when server is able to respond you back, it also responds back with the status code. Okay, if status code of 200 means it is success, which means your get request reached the server and you got the response. In some cases, probably your client, would be sending a wrong request, or if the server is not available to handle the request. So you will get, the errors like 404 error, 500 internal server error, 501, 502. So there are a lot of error codes. So depending upon the error codes, you should know why your request failed, whether the request failed due to your issue, or the request failed because the server is unable to handle the request, or the server has no information regarding your request. It can be anything. Okay, but when you want to create information on the server, okay, it is always a post request. Let's say the server is your Docker daemon, and the daemon, inside the daemon, inside your Docker host, you wanted to create a container, let's say nginx container. Okay, so when you're sending a post request to the server, you also require to send some data, like what container name to be used, image to be used, ports to be opened, all that information. So that when you're sending a request only, you need to send some information in the body of that request. Then only server can read this body and understand what container or what information you wanted to create on the server side. Clear? Clear, guys?
Vikram, one doubt. Hello.
Yeah.
Yeah, so since the output is in JSON format, it is called as REST in specific, or like,
Yeah, so RESTful means it is representational state transfer, which means the data is being transmitted in form of a representation. Okay, like it will be mostly data which is easy to be parsed. Okay,
okay,
not image related, not HTML pages, not CSS related information, nothing like that, because these are two different tools. One is client and one is your server. So in most of the cases, client will be very lightweighted. Okay, so they don't understand most of the things other than the formats like JSON, XML, something like that. They cannot understand your HTML responses or something like this. And also these are used only because you have the RESTful way of communication because you wanted to talk to the server and get the response in a faster way. Okay, not like you talk to the server, server will send you HTML pages and all that heavy weighted information. Okay, it is not like that.
okay,
That's the reason why the data is always sent in the form of a state representation, like a JSON format.
okay. What are the other form of opposite to REST usually? The names.
No, REST itself is a style.
Okay, I
That's why
mean,
we call it as
different
RESTful
types
APIs.
when you say other than REST usually.
Other than REST, you have various other protocols. You have gRPC
Okay,
protocol is there. Okay.
okay,
But ideally, the data will always be JSON. Okay.
okay, okay,
So the server can also send the XML information, but we always try to get the JSON response from the server so that it is easy to parse. Okay. Now, if you look at the APIs, right? So if I just go to Docker daemon APIs. Yeah, someone raised a hand, please. Okay, if no one. Okay, so we will go to this engine API version 1.43 reference. See, I already pasted all the links in this document, okay? But I'm not going through that links. I'm just showing it here. Okay, so the Docker Engine API is 1.43 is what they're saying. But if you want to know what API, API version that your Docker daemon is using, just simply do Docker version. Okay. So here on the client, it is 1.43. On the server, it is also 1.43. Okay. But when you want to talk to the server, that is daemon. So the minimum of 1.12 is required. Okay. But 1.43 is what we will use. So these are all the engine APIs. Okay. So let's say I wanted to get the version information about my daemon. Okay. So this is what we need to send. Okay, on the right hand side, uh, where is the version? Yeah, so they said you want to send the information on this one version. Yeah, this one version 1.43 slash info. Okay, so this is what you need to. This is the API endpoint. We call it as an endpoint because so here we are not including um, any IP or host related information where Docker is running. Okay. But where exactly your Docker is running now? It is localhost. Okay. Because we have both client and the server running on the same machine. Okay. So we call it as localhost. That's the reason why I'll use HTTP colon slash slash localhost. So I'm talking to the localhost. Okay. So this is the proper URL. So using curl, I can basically reach this particular local host. Okay. But the thing is here by default, it is taking the HTTP protocol and assuming that this localhost is nothing but localhost colon 80, which means there should be some service that listens on 80 in order to handle this request. But there is no such service like Nginx or HTTP, which ideally listens on 80. Those are the web servers, right? Correct. Here we are directly connecting to this using our HTTP protocol. But by default, your client will talk to the daemon over Unix socket. So how can I pass that Unix socket inside this curl request? Okay. So I think curl -h will not give you that. There is no advanced options here. But here you have an option called curl hyphen Unix hyphen socket, and then you need to give the Unix socket. It is var uh, docker dot sock. Okay, and then we are trying to reach this. Okay, now you can see you have response from the daemon. Okay, got it? So this is a huge information. So this is JSON. So you need to know how to parse it. Okay. I can use VS Code and then save that file as JSON. That also I can do so that JSON will be properly formatted, or you can opt for any JSON parser online and simply copy paste that entire data. It will be formatted. Okay, easily. Okay, you can see here. This is you have some options here. Parse JSON, evaluate JSON. Okay, let me click on colorize and all these things. Okay, so now if you just expand, okay, so this is your complete JSON. Okay, let me turn off this which one, eval JSON. Okay, so let me put only um eval JSON. I'll turn it off. So this is your entire JSON file. Okay, got it? So here you can see the ID, number of containers running, the driver statuses. Okay, a lot of information, what plugins you have. whether debug mode is turned off or not, which architecture, OS type. Got it, guys? See, complete information about the Docker is now returned to you in the form of a JSON. So if you're using Python, okay, to call this particular daemon using the Unix socket, okay, your Python will receive this JSON data, and after that I can parse it. Clear? Understood, yes.
Hmm.
Okay. Not only this, let's say, let me just use Docker images. Okay, so this is a command that your daemon is receiving using Docker client. Okay, so let me pull an image, or before that, let me see how to use the same curl command to get list of images on this host. Okay, if I go to this images and list images, just on the right hand side, you will have list images. Yeah. So slash images slash JSON. Okay. So this is what you need to provide. Images slash JSON. See, currently there are no images. Let me pull using Docker client tool. Okay. So Docker pull Nginx. Okay. Now I pulled this image. If I now run this command, you will see, an image. Okay. So what is that image? Nginx latest. So what is its size? Size in bytes. Okay, got it? Similarly, you can also delete image. Okay, so let's say remove an image. So for removing an image, and of course, I forgot to show you the HTTP method you have to use. If you use list images, you can see it is a GET request because you're trying to get some information from the server. And if you want to remove an image, you can see it is a delete request. Okay, and if you expand it, it will show you the proper the command that you have to use. Got it? Clear, guys? You also
Yes.
have the information here. So let's say I wanted to delete. Okay, so I wanted to delete this. Okay, what is the API endpoint? It is images slash name. Okay, so the name is Nginx. But if I send this request like this is nothing but a GET request. Always remember the default request will always be GET. Okay. So let me just comment this line and get the help of the curl command. So using -x, okay, you can actually define the, the method you have to use. Okay. So let me use curl -x. Okay. Or else it is not there in that help section. Curl mention HTTP method. Okay, how do you mention? So using curl -x followed by with whether it is get, post, delete or something. Okay, so you can use this site. It is important. Let me search for probably -x. That will also give me. Now you can see I can use curl -x post or something, or else I think it is hyphen request. Yeah, see here, it is either hyphen request or -x. You can use anything. So this command I'm modifying, I'm saying curl hyphen request. So this request is now the delete request. Okay, now you can see our image got deleted. Okay, so I will use Docker images. You can see there are no images. Using curl command also, I can list all the images, right? Images slash JSON. You can see it is an empty data. So this is how we use the Unix socket. But the main thing that we wanted to discuss is, how to enable the TCP communication. Okay, so this is what we need to understand. Okay, So if let's say you have client and the daemon available in two machines, okay. So this is one of the EC2 instance where your daemon is running, okay, and you have one more EC2 instance where your Docker client is only installed. There is no daemon here, okay. So Docker PS and all these commands will fail. So now over the network, I want this client to talk to this daemon, okay, over TCP. Okay, so it has both with TLS and without TLS. We will see what we will see without TLS now. Okay, uh, so this has to go through the network. Okay, now we know that this daemon by default runs on listens on Unix socket. Okay, so which means if you have the Docker CLI here, only this CLI can talk to this daemon using Unix, or else you need to use curl commands here to create the containers or images here. But how do this client will talk to this daemon? This client doesn't have the access to the Unix socket, right? It doesn't have on the other machine, on the server machine. So it has to go through the network. So that's the reason why we enable TCP communication, where this daemon, along with listening on Unix socket, it also listens on a port number called 3275 over TCP. So now this client, okay, so this client will talk to this daemon, okay, over 2375 port, okay, which means when I do Docker PS, okay, this Docker PS or Docker CLI will check for the Unix socket in the same machine and try to connect to the daemon. It will fail. But now we will configure Docker client in such a way that it won't look for the daemon here. It will talk to the daemon on the other machine. Okay. Which means if I have CLI in this machine, I can create anything inside this Docker machine using Docker related commands. Clear? Clear, guys?
Clear.
But what is the disadvantage of with this is, so here this daemon just listening on 2375. Anyone who has access to this port, they can easily talk to the daemon, create containers, destroy containers, access your data. They can do anything. The reason why we are saying this is here, this client is not, it is not authorized by this daemon. I mean, not authorized. You can say it is both authorized. It is only authorized because there is no authentication here as of now. Okay, so here this client can be anyone. It can be a hacker, or it can be you, it can be anyone, because the daemon is simply listening on 2375 without any TLS. Okay. So in the next session, what we will do is we'll try to secure the communication between client and daemon in such a way that this daemon will only accepts the request from certain clients, not from all the clients. Okay. So where we'll try to secure the TLS TCP communication using TLS, that is transport layer security. Got it? But for now, we will try to just understand how to configure this TLS without any communication over TCP without any TLS communication. Okay, so how can you actually do is, so basically you need to add, modify Docker daemon in such a way that it also listens on 2375 along with the Unix socket. Always remember, if you have this file descriptor, okay, so which means your daemon is listening on Unix socket. -H means host. So here it is listening on the Unix socket. Now I'll add one more host, okay, in such a way that it also listens on 2375. Since I'm modifying the daemon file, I have to reload the daemon and then restart Docker. So it starts to listen on 2375 again. Okay, so this is one way. Okay, now on the same machine, so you can use curl command and then you can directly talk to 2375 port. No need to use -- socket, because your Docker is also now listening on 2375 port. Okay, clear, guys? Understood. What about if I want to talk to this daemon from other EC2 instance? Simply replace this local host with your daemon's IP address, your daemon, EC2 instance IP address where your daemon is running. That's it. Correct. Now the request will come to that daemon because you mentioned that IP address. It will talk to 2375. Clear?
So this is for restricting clients to talk to
Okay, so
the.
if you have EC2 instance, you have Docker daemon, which is also now listening to 2375. Okay, so using curl command, you will now target localhost colon 2375 to talk to the daemon. But let's say I have one more EC2 instance. Okay, using curl, I can reach this daemon, but the problem is I should not use localhost because localhost means it will be here. Okay, now localhost has to be replaced with the IP address of this machine, right?
Right.
And over 2375. So it will talk. So this is one method. Okay, using curl for automation and all. What if I have to use this Docker client CLI to talk to this daemon over 2375? Because if I do Docker PS, the default it uses Unix socket so that it will look for this daemon here. But this Docker PS has to look for the daemon here. Okay, so for this we will have some client configuration. See, this Docker is client. Docker D is daemon. So Docker client also has some configuration. Daemon also has some configuration file. So we will make sure that this Docker client uses this as the TCP port, I mean the TCP related information and not the Unix socket. So that this Docker PS will always use this URL to reach this daemon. Okay. So let me quickly show that as well. Okay, so this is one method where you modify daemon to include 2375. Okay, let's say you want to disable Unix socket. I don't want my daemon to listen on Unix socket. Simply delete this entry here and have only TCP. That is one method. Okay, let's say you don't want to modify service file. So there is one more way. So this Docker daemon also has a configuration called daemon.json, which will by default is not existing. So you can create this etc docker daemon.json file. Okay, and then add the host's related information in the form of a JSON. This is a JSON because you have two parentheses. So within this host, you put host and then mention your TCP's information. If you also need daemon to listen on Unix socket, you also include that Unix socket related information. But if you're adding hosts here, make sure that this host related information, whatever you have in the service file, are deleted first. Okay, you can't have hosts here and hosts here. Docker daemon will fail. Okay, correct, guys? Okay, so let me quickly show you that as well. So I'm currently in my
Vikram?
one daemon. Yes.
So network socket is different from Unix socket?
Yeah. So Unix socket, it is for this particular machine only. So network means you can talk to this daemon over from the other instances.
Okay.
Okay, so the main use case that we have for adding this TCP socket is, let's say you have Jenkins master. Okay, so this Jenkins master, it is the main system, but you cannot run your Jenkins jobs here. Okay, I want these Jenkins jobs to run inside a container, and the container should be deleted as soon as this job gets completed. Okay, so this I'm doing to unload the master and also to have master slave kind of setup. Okay, now let's say your Jenkins master is a physical VM. Okay, it is running on some EC2 instance. Okay, so now I have another EC2 instance where Docker is installed. Okay, now I want this particular Jenkins to create a container for every job. So for this job, container C1 will be created. Once the job is completed, this will be destroyed. Now, when the user triggers one more Jenkins job, another container will be created and then it will be destroyed as soon as the job is done. Got it? Clear?
Yes.
Now, how this Jenkins talks to this EC2 instances, Docker daemon, they are not on the same machine. They need to use the TCP. That's the reason why in this instance, you enable the TCP communication so Jenkins can talk to that daemon over 2375 or 2376 if TLS is enabled. So that this Jenkins master can talk to the daemon, create the containers, destroy the containers, like that.
Uh,
Okay?
Master, we have the CLI.
No, master we have the CLA, correct. Master need not have the CLI. It can internally use the curl command also, right? It can directly consume the APIs.
Yeah.
Okay. Now, how do I configure? As I already said, we need to modify the daemon. Okay, so for that, that service file is in libsystem d system. Okay, so there is this file called docker.service. Okay, so here what I'm doing is, if you see here, by default it is listening only on the Unix socket. Okay, so here I want it to listen on port number on 2375. Always remember, put only zeros. If you hard code IP address, or if you do 127.0.0.1, it is going to fail, because we want others to listen to this socket. I mean, to talk to this daemon on this port number. Always prefer all zeros colon 2375. Okay, so now let me just save this file.
I need to
Uh,
use a standard port, this port only, right? Can't be any random, right?
yeah, you can use any port. That's fine.
Oh, okay.
You have to change it in the configuration. Okay. So now what we have to do is we have changed this daemon. So you have to use systemctl daemon reload. Okay. So anyways, if you try to do systemctl restart Docker, your system will prompt you to run daemon reload command first. Okay. So we have restarted Docker. Okay. Now you can do Docker PS because you have access to the socket. Okay. And if I just check netstat -tulpn to show you, see Docker is also listening on 2375 now. Okay. Now what I can do is I can simply use curl. I can use Unix socket. Okay. So I'm on the same machine. So I will use HTTP localhost, and then /1.43 is API number. Images slash, I think JSON. I think this is the command. No, what is the command? Unix socket. We did not provide the Unix socket. Okay. That is var run docker.sock. Also, there is this wrong. It's var. Okay. Message page not found. Okay. What is the listing of the images? What is the endpoint? List images. It is images / JSON v1.43. Okay. So it is v1.43. Okay, now you can see it responded. But here we are trying to connect to the daemon on the same machine using Unix socket. I don't want to use Unix socket, so I'm just removing this method of communication completely. I want to connect to the Docker daemon over 2375. Okay, see, I got the information. Now the Docker daemon is listening on, okay, TCP and Unix. But in order to prove that, what I'll do is I'll create one more instance. Okay, I'll call it as some Docker client, because I'm going to install only Docker client inside that, not complete Docker. Okay, launch instances. Okay, and also one more thing, since this Docker daemon is listening on 2375. Okay, so in order for the external tools to talk to the 237 port or 2375 port, we need to open inbound rules in the server. Okay, so I'm including 2375. For tomorrow's session, I'm just going to open 2376 as well. Okay, so I'm opening both for now and save. Okay, so let's.
Vikram, while that comes up, generally, I mean, whether it may be Nginx or Tomcat or any application, generally we make sure that it listens on a port style, right? Like a port.
Yeah.
Why specifically Docker uses this unique socket style of interactions?
Because by default, you always talk to the daemon using the client on the same machine, right? There is no need of networking for that. Okay. So I'm just logging into the other machine which I just created. Okay, I'm going to just call it as Docker client. Okay. So this client is just like any other machine. Okay, it won't run your Docker daemon. I'll show you. Will it come up? Okay, so this is another machine. Okay, so let me become sudo. It's not required. Now what I'll do is, see here we just connected to the the daemon which is running on the same host. Now using this another VM, now I can talk to the daemon on the other host by simply replacing localhost with the IP address of the server where your daemon is running. Okay, got it? You can see I'm getting the response. Clear? If I do Docker PS, it won't work because Docker itself is not running in this machine. Okay, that is another thing. And also, since anyone can run these commands, okay, so this is a kind of a security issue. So you need to enable TLS based communication between the client and the server, which we will see tomorrow. But so I want this Docker, this client, Docker is a client, right, to talk to the daemon on the other machine. But I don't want to install daemon in this machine and client at the same time. I just want the client tool. So for that, you can just go to download.docker.com. Okay, so here you'll have Linux, Mac, and Windows. I'm just taking Linux, CentOS. Okay, so I will take 9/client, this one. And my architecture is x86-84. I'll take stable. No, this one. Just go one step back. I think packages. Okay, so here I'll have Docker CE, which is your basically daemon. If you see Docker CE CLI 20.10, so this is the RPM file. Okay, so this is the client. So let me just copy the link at it. Just see if CLI has the latest version. Yeah, latest version is there. It is 25. Okay, this one I will take. Just copy the link address. Go to the other machine. Just go to the /opt somewhere. First download this RPM file. Okay, so this is for the CLI. Now RPM file can be loaded using RPM-I and the name of the file. Oh, sorry, not RM, it is RPM. Okay, so it is now installing Docker. Okay, so now if you do Docker, let's say info, okay, so you will get the client version. Okay, but server you won't get, because by default this client is trying to talk to this particular unique socket, but daemon itself is not installed in this machine, right? Correct.
Right. Right.
Now if I do Docker PS and all, it won't connect because this Docker client is by default sending the request to this unique socket. I want the Docker client to send the request to 2375 port, okay, on the other VM, this one. Okay, so how do I do that? So we know that for daemon we configured in the service file, right? Okay, but this is client. So how do you configure a client? So the client can be configured in two ways. So client has its config file also. So there is an environment variable. Okay, so if I go to Docker CLI configuration, okay, something like this. So using the Docker command line. Okay. So I can also go to the CLI reference here. And so these are some of the flags. See here, Docker -- host or -h. So which means when I'm running this Docker command, I can pass -- host or -h. Okay. So which is Docker PS. But before that, I need to pass the host related information, because the by default it will connect to the Unix socket. Now I want it to connect to 2375 port on the other Docker server, right? So this is the IP address where server is running, I mean daemon is running, and on port 2375. Got it? See here, I'm talking to the daemon on the other machine. Okay? Clear, guys?
Yes, Vikram.
Clear.
But every time passing -h is not suitable for me. So what I'll do is I'll see if I can configure it in some other way. So using the Docker command line. So these are the environment variables supported by the Docker client. So there is an environment variable called Docker host. Okay. I'll just copy it and I'll create this environment variable. Okay. I'll set this environment variable using export command, and I'll set this environment variable to TCP : // I'm asking it to use TCP and then connect it to this host. Now, my Docker host will see whether it has this Docker host environment. I mean, my Docker CLI will see whether this host environment variable is set or not. Okay, anyways, it is now set. Now, if I directly use Docker PS, it is going to read that host environment variable, and it will automatically connect to my other host. Okay. So I'm in the other machine, which has only client. Now this client is able to talk to the server, which is on the other machine. Got it? Clear, guys?
I should mention TCP, right? Not HTTP.
TCP, yes. Okay. I think if you go to this one, okay.
But on other mission, there was no Docker installed, right, Vikram? But how come we are able to use
Sorry.
Docker? On other host, second
Hmm.
host,
Hmm.
there was a Docker was not installed.
Yeah.
That is the reason in the first instance you showed with the curl command.
Yeah, correct.
Now you are using a Docker command.
Correct.
So you have installed Docker, or how is it getting the Docker commands?
No, I just installed the Docker CLI, right? By downloading the RPM file.
Oh, okay.
Okay. So if you don't
Uh,
want to use environment variables, Docker
Vikram,
CL, yeah.
there's one doubt. Like we have the service file,
Hmm.
so can't we configure that service file in another EC2 where Docker is not installed?
But what is the point if the Docker daemon itself is not installed? Who is
Okay.
going to use that service file?
No, I thought that in that
Hmm.
service file we can configure that IP with the
See,
TCP.
that service file is for the daemon.
Okay. Okay.
This environment variable is for the client. See, client also has a configuration file, as I already mentioned. So that file will be with the config.json, okay, under this .docker folder. So where you can actually, instead of using this export command, okay, so you can also use that particular config.json, but it's not required. If you want, you can refer this documentation to configure. But for the daemon, it is important. So in the daemon, we are actually, what we are actually doing, we are actually editing that service file here, right? Okay, so we should not actually use this service file. We can use the daemon configuration file. Okay, so for that, what I'm currently doing is I'm removing this, entire host related information from the service file. See here, both -h should be removed. It's not only one. Okay, now let me just save this file, reload daemon, and then start this service. Okay, so now Docker host is not listening, okay, on the which one?
2375.
2375. But the default one is Unix socket. That's the default one it will use. Okay.
Yeah,
If I go to the client and then simply to Docker image ls, now it
it
will
will
say
not.
that it will not work. Okay. So
Yeah.
in Docker, there is a file called, this is for the daemon, remember? The file called daemon.json. Okay, this file won't be available. You need to create it. Then here I'm going to add the host related information. So I'll say host. Okay. So these hosts will take, array of values. So that's why it is, you should put it in the arrays. Okay. So it can take any number of values separated by comma. So currently I'm just asking it to listen only on the TCP port, not on the Unix socket. Okay. Got it? So 2375, I mean TCP 0000 colon 2375, and then simply, save this particular file. Okay. Now, if I do Docker PS, I think daemon is, I need to restart Docker. Okay, so it says it failed. So let me just see why it failed by, running this journalctl command. It says fail with exit code. Okay, I think when we, let me see whether we have changed it properly or not. VI into libsystem system. Yeah, we removed it. And cat etc docker slash daemon.json. Okay, 2375. Just a second. What is that syntax? Okay, that syntax anyways I can also show in the web. I'm just checking it here. In the presentation also I gave TCP, and this is fine. Unix socket. Okay, so let me also copy the Unix socket for time being along with the TCP information.
The
Okay,
host should
just
be ports, I guess.
I'm just using both. Okay, now do Docker PS. I think Docker is not running. So systemctl register. Okay, daemon reload has to be done. And then restart Docker. Yeah, I think daemon reload command I have not used. Okay, now if you do Docker PS, it is working again. In order to see whether it is still listening on 2375, you can see it is still listening on 2375. If I go back to the other machine now, you can see it is trying to connect. Okay. And coming to, so how I used this etc daemon.json is, if you go to the web and search for Docker daemon configuration, okay, Docker daemon configuration overview. Okay, so here, uh, configure the Docker daemon using either Docker D using its flags. Means -h is like a flag for the host. You can configure the daemon using -h flag in the service file, or else you have a configuration file for Linux under etc docker daemon.json. Okay, for Windows, this is the location. Okay, and what all configurations you can create is, okay, you can basically use this as the JSON configuration. Data root is one such configuration, but if you want to know all the configuration, just use Docker D reference docs and you scroll to the bottom. This one. Okay. This is a full example of this daemon.json file. And if you see, we used hosts, right? Here, this. Okay. Clear?
Yes, Vikram.
Okay. So this is how you actually use this daemon.json to configure the which one? The host on which daemon will listen. So in the next session, when we talk about configuring the TLS, we will use TLS based configuration in the same daemon.json so that now your Docker daemon is protected. So you have the TLS related information here. These 5 configurations we will do in the next session to enable TLS based communication between the client and the server. Okay.
Vikram, one doubt. So can we apply the same concept to if I want to install Docker inside a Docker? That's how it works. I mean, is the
Hmm.
Docker by
So
default?
Docker inside a Docker, yes, you can use the same thing. Okay. So like either you can, basically let me draw and show. So basically when you have a Docker host, right? This is your Docker host. 1 second. Okay. So if you have, let's say Jenkins running on this. Okay. So now this Jenkins, for its job, it wants to create a container. Okay, so when I issue Docker run command inside this Jenkins container, this is already container. Where exactly that container gets created? Here, right?
Yeah.
So it is like Docker inside Docker, which poses a lot of security issues and it is not easy. Okay, so what ideally you should do is you should run,
Easy.
let's say if it is your Docker host, you have var run docker.sock file here. Okay, and then let's say you already have a container, Jenkins container. Okay, so inside this Jenkins container, what I should do is I should make sure that only Docker CLI is installed. See, if I have CLI and if I have access to the socket file, it is like I'm trying to talk to the daemon only, right?
Right.
What I will do is I'll take the socket file which is running on my host and I'll try to copy it into the container, Jenkins container. Now, whenever Docker, commands are executed inside Jenkins, like Docker PS or Docker run, so it will take this socket file, which is readily available inside the Jenkins container. But the socket file is nothing but it is a mapping to the socket file on the host, which means if I simply do Docker run to create a container, it will Docker CLI will talk to this particular unique socket, which is nothing but this unique socket. Now, whatever container that Jenkins is trying to create, it will be on this machine. Okay.
Do I need to copy the Docker socket? I mean, by default, container doesn't have the Docker dot
No,
socket.
by default, containers will not mount that socket. Okay, it is only your Docker CLI that talks to this socket to create these containers.
No, I mean,
Okay.
container itself doesn't have the Docker dot sock.
No, container will not even have Docker CLI. You need to make sure that you either create a customized Jenkins image, okay, or customized Jenkins image with Docker CLI installed. And then when you're creating this container, make sure that this socket is mounted into your container in the exact same location inside the container. That is var run docker.sock.
Using this volume mount implementation.
Yeah, but this is also not a recommended approach. Okay, so the ideal approach is you need to make sure whatever daemon that you have, it should listen on some socket, some TCP port, and make sure that your CLI is configured to talk to that socket. And also make sure that the CLI and the Docker socket communication is encrypted. Okay, to securely establish the communication. So this var and docker.sock is one of the easiest methods available, but you should always try to avoid it.
Okay.
Okay.
Just to confirm, if I on the Jenkins container, if I just put yum install Docker, will that actually installs Docker and
Daemon as well.
so it will get
Mm.
Docker and CL. So
See, once you install Docker, CLI and daemon, if you don't start the daemon, that is fine. Only your CLI will work. But the problem is Docker daemon itself takes some space, right? So why to install daemon if you can install CLI separately?
yeah.
Okay. If you install Docker, that is fine. Anyways, it won't run by default.
No, my question is like if I just put install Docker, so it installs CLs and daemon. So at least that works inside Jenkins. I mean, that's my question. It works as
Yeah, it works.
okay.
Jenkins can install any package. So if you so tomorrow, day after, so by Monday, anyways, we are going to start with the Docker file, right? Then you will understand how to customize the images and all.
Vikram, I don't really understand everything you've taught today.
Yeah, that's what I said, right?
Okay.
So without a proper hands-on, you will not understand today's session. But the reason
Okay.
why I just taught this is because you will understand the importance of the APIs, importance of configuring your tools, understanding in depth of each and every tool. It's not like that you simply did Docker run to create a content, but in case if someone asks you, so what is the process behind how the communication flows, you should be
Okay.
able to answer it, that it talks to the socket first and daemon is listening on the socket, and that's the reason how daemon will take the instructions from the client. Now you should know that entire end-to-end flow. That's the reason why I had to teach this.
Okay. Yeah, I'll watch the recordings over
Yeah, so
again.
once you watch the recording, it will be easier for you.
Okay. Because I was wondering if I'm the only one feeling this way in this class.
Yeah, but it is really important going forward
Okay.
because Kubernetes, Nexus, SonarQube, all will understand the APIs, all has the APIs.
Okay.
If you don't understand these APIs, how the process flows, Kubernetes, you can't answer some of the questions as well.
Yeah.
Now it is as like you have AWS cloud, but you are using AWS CLI to create the instances or to create the resources, right?
Yes.
But how AWS is able to communicate, AWS CLI is able to communicate to AWS cloud. Again, there is a communication protocol involved. And then you do AWS configure to configure your IAM credentials in your local machine to talk to the cloud, right?
We
No.
I haven't seen this part of Docker actually. I mean, Docker run images commands generally. I mean, this understanding is
Yeah,
actually
so this you will understand only if you have good understanding of how to browse the documentation. So if you see, I entirely relied on the documentation today. Okay, so that is how important the official documentation is. It has everything. Okay, any questions? Okay, so now I have a task for you guys for tomorrow. So if you go to my channel and if you go to the playlist, so there is a playlist called TLS Mastery. Okay, TLS Security. So here all these are open. So these are not restricted to any members. Okay, so I want you guys to understand the first video. If you can go to second video, that is fine. Okay, but I want you guys to go through at least the first video. Okay.
Yeah.
Okay.
So this explains what is TLS, what is TLS communication, what is encryption, types of encryption. Okay, what is a certificate? What is a self-signed certificate? How do you procure a certificate? Okay, how do you say that a domain is certified by a certified CA? Okay, it has a clear content on TLS.
Okay.
Okay, if you understand this, tomorrow's class, it is really easy.
Okay.
Okay, but you have to go through these videos. They are lengthy, but at least try to complete the first one.
Okay.
Okay.
Yeah.
Yeah. So let me just start it, and then let me just show you what all content it has. So here you will understand all this: SSL, TLS, HTTPS, what is S, what is PK infrastructure, what is certificate authority, what are self-signed certificate, what is a certificate signing request. Everything is there in depth. Okay. Got it? And then in the next video, there is a demo. So where you create your own certificate, you sign your own certificate, and you put that certificate on the Chrome or any other browser, so that Chrome can detect that, certificate and make your site from insecure to secure. Okay. Got it? Any questions?
The certificate should be at the server, right? Or it should be on the client.
See, certificates can be generated for both.
Okay.
Okay. If you are creating a certificate for the server, so which means you are just saying that the server is a proper server managed by a proper organization, and it is secured. It is an authorized server. Okay. But what about clients? Okay. So client certificates are generated automatically by some tools. Okay. Like Chrome. So when you're talking to a server like youtube.com has some certificates.
Yes.
But you being a browser, so you are a client.
Right.
Are you generating any certificates before sending the request to youtube.com or google.com? No, right?
No. Yeah.
Your Chrome is going to automatically generate them, and then it is going to send it. But when you're talking about client server model like Docker and Docker Daemon, you need to create certificates for both server and client, and then sign them with the proper certificate authority, saying that whatever certificates that CA has signed are genuine and validated. Okay. That is how a trust will be established between client and server.
Right.
What is a self-signed certificate is if I sign the certificate myself. Let's say I say that I'm certified in AWS, but who is going to authenticate it? Like who is going to, just check the, genuinity of that certificate?
Authentic.
It is with the
AWS.
credentials, right? AWS
Yeah.
is going to provide me some credentials,
Right.
certificate ID on something. Okay, I can't simply say that I did this certification. It is just like say I'm certifying myself. That is self-signed certificate. Okay, self-signed certificates are free because I'm certifying myself. But if it has to be certified by from known certified certification authority or CA, so it is going to cost me, right? Just like I'm giving AWS certification to get this certification, to get certified, it costs me.
Correct.
Okay, so you cannot, get the certificates from proper CA just for your testing because it is going to cost you. So we are going to create our own self-signed certificates. And also, if you just visit, if you create any domain, so you're going to get a certificate for the domain for free from most of the hosting providers. So that is one way you can get a free certificate. Okay.
Yeah, understood. Yeah.
Okay. So if you go through these two videos, right, you will understand about TLS. You will never need another video on TLS again. That's for sure.